వీక్షక మహాశయులకు మా ఛానల్ పలుకుతోంది స్వాగతం ఘనస్వాగతం. Today we are going to discuss what is a variance of a random variable. What is a variance of a random variable? My dear viewers, we will study in detail about the variance of a random variable. Yes. Variance. The variance of a random variable x is defined as variance of x is equal to sigma suffix x whole square is equal to, or simply sigma square is equal to e of x minus e of x whole square. So, in general, the variance of a random variable x is denoted by VAR within the brackets x or sigma suffix x whole square or sigma square. In probability and statistics, variance is the expectation of the squared deviation of a random variable from its mean. Informally, it measures how far a set of numbers are spread out from their average value. Variance has a central role in statistics, where some of the ideas that use it include descriptive statistics, statistical inference, hypothesis testing, goodness of fit, and Monte Carlo sampling. Variance is an important tool in the sciences where the statistical analysis of data is common. Now, my dear viewers, we will see some of the properties of the variance of a random variable. So, the very first property is variance of 1 is equal to 0. Number 2, variance of x is equal to e of x square minus e of x whole square. Third one, variance of c times of x is equal to c square times variance of x. And fourth one, if x and y are independent, please remember, if x and y are independent random variables, then the variance of sum of the two random variables is equal to their sum of the variances of x and y. That is, variance of x plus y is equal to variance of x plus variance of y. If x and y are uncorrelated random variables, then variance of x minus variance of x plus y. Now, we will study that covariance of two random variables. The covariance of two random variables x and y is defined as covariance of x comma y is equal to expected value of the product of the random variables xy minus the product of the expected values e of x times e of y. My dear viewers, note that the expected value of the sum of two random variables x and y is equal to sum of their expected values of x and y only if x and y are independent. That is, e of xy is equal to e of x times e of y. When I substitute this property in the covariance definition, the right hand side will be equal to 0, because e of x y is equal to e of x times e of y. So, if x and y are random variables, then please note that the covariance of x and y is equal to 0, since we have this property. E of the product of xy is equal to the product of e of x times e of y. Now, my dear viewers, let us see some properties we will derive for the variance of the random variables. The variance of sum and difference of two random variables x and y is defined as, let us see, variance of ax plus by is equal to a square times variance of x plus b square times variance of y plus 2ab times covariance of x comma y. Similarly, the difference, that is variance of ax minus by is equal to a square times variance of x plus b square times variance of y minus 2ab times covariance of x comma y. So these are the definitions for the variance of sum of two random variables and product of the two random variables x and y. Now suppose a is equal to b is equal to 1. We obtain, what happens for these two definitions? Variance of x plus y is equal to variance of x plus variance of y plus 2 times of covariance of x comma y. Similarly for the difference, yes, variance of x minus y is equal to variance of x plus variance of y minus 2 times of covariance of x comma y. Yes. Suppose if the random variables x and y are independent, then the covariance will be equal to 0. Just we have observed in the previous slide. So if x and y are independent, then the covariance of x comma y is equal to 0. And hence what happens for these two definitions? Yes, variance of x plus y. So covariance will be equal to 0, then you will have variance of x plus variance of y. For the difference, yes, covariance is 0, same, variance of x plus variance of y. That means variance of x plus y is equal to variance of x minus y is equal to variance of x plus variance of y. That's we have derived one of the properties of the variance. Now let us see. Variance is invariant with respect to change in a location parameter. That is, if a constant is added to all the values of the variable, the variance will be unchanged. Please remember, the variance will be unchanged. That means variance of x plus a is equal to variance of x. So that variance is invariant with respect to changes in the location parameters. Now, variance of a random variable is always non-negative. The variance of a random variable is always non-negative because the squares are positive or 0. That is, what we have the definition of variance of a random variable? Yes, variance of x is equal to sigma suffix x square is equal to sigma square. That means squares are always positive or either 0. So that variance of a random variable is always non-negative. That is, variance of x is greater than or equal to 0. And now the variance of any constant c is always equal to 0. That is, variance of c is equal to 0 where c is any constant. Very first property of the variance is variance of 1 is equal to 0. Not only for 1, for any constant c, variance of c is always equal to 0. Okay, my dear viewers, thank you for watching our videos. Please subscribe our channel to get more information on probability and statistics. Thank you once again.